Today what we want to look at getting into this next lesson is we want to be able to work with equations that have decimal numbers involved. And there's an easy way you can get rid of decimals when you're solving equations if you don't like working with decimals. And then the other thing we want to work with is consecutive integer problems. When you look at consecutive integer problems, you may need a note card. So if you want to go ahead and get that out now, to jot down just a little bit about what you know about consecutive integers that will help you with that particular type of problem. Did she shut the door or should she go get her note cards?
Yeah, your note cards.
Yes, I would love for you to go to your locker and get your note cards. Thank you for asking. Oh, you went to shut the door. Okay, so two things we want to focus on again, equations with decimal numbers and then consecutive integer problems. So if we look at the first thing when we start working with equations with decimal numbers involved, eventually they're going to have us work with story problems that involve this. And as long as you can read decimal numbers, that helps. So if I asked you to read this first equation, what place value is that 3 in? Thousands. Tenths is the first place after the decimal point. Tenths, hundreds, thousands. The 3 is in the thousands place value. So this is actually read as 3,000 x plus, what's that next term? 4 tenths is equal to 2 500ths. So how do I solve a problem like that? Well, I think most of you would realize that what you need to do is I need to move the 4 tenths over to the other side by subtracting it, do the opposite operation. And oh yeah, when I subtract decimals, I have to line up the decimal point. So then I go ahead and I subtract. The 2 becomes a 1. I have to borrow. I get 1 6500ths, and that's equal to the 3,000 x. So what do you have to do as a final step? Divide by 3,000. So then I'm going to go through and I am going to divide by 3,000. But when you divide by 3,000, which number goes, which one's the dividend, which one's the divisor? The dividend goes underneath the division sign. What goes underneath the division sign? 1 6500ths. So I'm going to have 1 6500ths. And I divide by 3,000. Oops, the wrong value there. And I divide by 3,000. And how do you divide decimals? You move your decimal point over so that the divisor that you are working with happens to be a whole number. Sorry about that. There it comes back. So I divide. I move it over 3 places. So I move it over 3 places in the dividend. Move it straight up. And then 3 goes into 16, 5 times, which is 15. I have 1 left over, bring down the 5. Some of you do that. 3 goes into 15 5 times, and I get 15. And some of you accidentally stop and you say your answer is 55. But don't forget, you still have this 0, and it goes in there 0 times, and your answer is actually 550. So my answer, 550. Okay, who likes working with those decimals? No. But we know one truth or one legal move in algebra is that if you do something to one side of the equation, you have to do the same thing to the other side of the equation. Can I multiply both sides of the equation by 1,000? And it doesn't change the value of your equation, right? Doesn't change the solution to your equation. So here's another way to work through it. Same problem, right? 3,000 x plus 4 tenths is equal to 2 500ths. So I'm going to take both sides of the equation and I'm going to multiply by 1,000. Now, why did I pick 1,000? I picked 1,000 because if I look at this left-hand side, how do you take 1,000 times a quantity in parentheses? The distributive property. So if I use the distributive property, what is 1,000 times 3,000ths? 3. I now have a whole number. Ooh, we like whole numbers. We like integers. Easy to work with. I move the decimal point over 3 places when I multiply by 1,000. What does 4/10 become when I multiply by 1,000? Move it over 3 places and you get what? You have 4/10, and if I move it over 3 places, you get 400. So now this equation, it starts out as 3,000 x plus 4/10 now becomes 3x plus 400. Whole numbers. I like that. What does the right-hand side of the equation become? What is it, Jenica? 2,050. I move the decimal point over 3 places when I multiply by 1,000, and I get 2,050. All whole numbers. Why did I pick 1,000? Because I found the value that had the most number of places after the decimal point, which was right here. There's 3 places after the decimal point. So I want to multiply by 10 to the power of 3. Same number of decimal place values you have. So I move the decimal point. Here's the other way you could look at it. You could just say, oh, well, the most number of places after the decimal point is 3. So I want to move the decimal point over 3 places in every single term. There's a nice little one right there. And if I move it over 3 places in every single term, both left and right-hand side of the equation, I get this equation down here. But you need to have justification of why can I just move the decimal point in every single thing? It's because you're multiplying both sides of the equation by 1,000, which is legal in algebra. Whatever you do to one side, you do to the other side. Now, who would rather, you could do 2 different things. You could solve this up here, working with decimals, or you could solve this equation right here, working with whole numbers. Which one would you prefer? Whole numbers. I would prefer whole numbers. So this looks like a problem that you can handle now. To solve that, we subtract 400 from both sides of the equation. So 3x is equal to, if you subtract 400, you get 1,650. And then you go ahead and divide by your coefficient of x, which is 3. So you're going to take 1,650 and divide by 3. 3 goes into 16 5 times, which is 15. 1 left over, bring down the 5 times, which is 15. 0 left over, bring down the 0, and you get back to that answer of 550. Now you're not working with decimals, which is what most people don't want to do. Now, when you get into systems of equations, and you're solving systems of equations, which means you're given 2 equations, and when you are solving them, what you're looking for is an intersection point. If one is in decimals and the other one's in fractions, it's a lot easier to have them in whole numbers. So you can use a particular process to solve. So this is leading you up to a step in a future problem, which is to make them whole numbers so you can find an intersection point of them. So I think I have now a problem where we can set it up. The students found that, how do I read that number again? 15,000 of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all? How do you think you would go about trying to solve that? $15,000 of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all? I could set up an equation. I could say that 15,000 of the total number of teachers is what value? $300. They're completely fearless or brave. How would you solve that? It's a decimal equation again, right? I could change it into whole numbers. Move your decimal point over how many places? 3. If I move it over 3 places, you get 15t is equal to, if I move it over 3 places, you get 300,000. So if I take 300,000 and I divide by 15, what do you get for an answer? And I have 20,000 teachers. That's the total number of teachers. Okay, to me, that's kind of a confusing way to set it up. How many of you like box diagrams? We worked with them last lesson, dealing with fractions. This confuses anybody? You can solve it this way. But another way you can solve the problem is just set it up as a box diagram where we have what? You are either brave or completely fearless. This is not brave or completely fearless, and a total. Read this number to me again right here. What is it? 15 thousandths. That means 15 out of how many? 1,000 are completely fearless or brave. 15 thousandths of the teachers are either brave or completely fearless. 15 thousandths, I can show that as a fraction, 15 over 1,000. If 300 teachers fell into one of these categories, what's one of those categories? Those categories they're talking about is brave or completely fearless. If 300 teachers fell into one of those categories, how many teachers were there in all? Is this problem in blue easier than this problem over here? Maybe. How do you solve this problem? Cross, multiply, and divide. So I'm going to take 300 times 1,000 and divide by 15. 300 times 1,000, that's the 300,000 that we had right there. And to solve, you divide by 15. You're doing the same thing. Some of you, if you divide by 15, are going to say that 15 times 20 is the 300, and 20 times 1,000 is 20,000 teachers. There's 20,000 total teachers that you would have. Box diagram, which is probably the one I'm more likely to use if students like that better, which in the past they've liked that better than trying to set up a decimal equation. Let's look at another example. An analysis of the old woman's utterances showed that, how do I read that number? 932 thousandths were vaticinal. If she spoke 2,000 times during the period in question, how many utterances were not vaticinal? Oh no, now I run into a little bit of problems. How many of you think you could set up the decimal equation for that? Anybody? I think that would be difficult. But if I look at it as a box diagram, what are my categories? How many are not vaticinal, right? Then we have how many are vaticinal. And then we have what? Total. So as I read through, 932 thousandths were vaticinal. How do I show that in my box diagram? 932, I want that in the vaticinal, right? Out of 1,000. If she spoke 2,000 times during the period in question, what's 2,000 referring to? The total. So if she spoke 2,000 times, how many were not vaticinal? I can't cross multiply and divide yet. Why? Because I would have to know what's right there. How can I figure out what's right there? Subtract. If I have 1,000 total and I know that 932 are vaticinal, then the difference is how many are not. And what happens if you subtract that? You get what? You get 68. So I know this is 68. Now can I find that right there? Yeah. Some of you are going to look at it and you're going to say, oh, well, I don't need this piece of information right there. And then you're going to look at it and you have, well, I have 68 over 1,000 is equal to x over 2,000. And you might not even set that up. And you're going to say you cross multiply and divide. So I got to take 2,000 times 68 and divide by 1,000. So when I cross reduce here first, what's 68 times 2? 136. Now, if you look at it, these are equivalent fractions right here. Would you agree these are equivalent fractions right there? And equivalent fractions, what do you do to 1,000 to get 2,000? Multiply by 2. Instead of saying cross multiply and divide, sometimes you could just look at it as equivalent fractions. I'm going to take 68 times 2 to get my answer. Sorry. 68 times 2 to get my answer. Box diagram, being able to set it up in a box diagram. I think box diagrams can be very beneficial and help you save time on trying to write equations. But if you need equations, we can solve it as equations as well. This one is more difficult to set up as an equation because they give you what is and they ask you what is not. So normally what you do is you set it up as how many are. Here I look at it and I would say, well, how many are vaticinal? I would say, well, it's 932 thousandths out of the total of 2,000 in question. I would have to multiply that together, find the answer, and then subtract it from 2,000. So if I were to multiply that, I'm going to get 1,864. That's not my answer. That's how many were. That's what would go in this box right here, 1,864. And to find out how many are not, I would have to take 2,000, which is the total number I have, and subtract the 1,864 from that. And when you do that, you should end up back with that 136. So you can work through it with decimals, but you've got to understand what you're finding. And I think that's more confusing than if you just set up your box diagram and see what values you're looking for. Either method, I don't care. Find what method works for you in your own thought process, and I will help you develop that. Okay, let me back up here a second.